am describing more of an idea of parallax. But again, that's the only thing that I think we need to explain, because I'm saying that I don't believe in stellar aberration because I don't believe these distances are that vast. Therefore, they have no place. Just like stellar parallax does not apply to objects within the solar system on anything other than the sun, apparently. So that all I'm saying is that in our model, stellar aberration is not even a factor at all.
All right. Well, now you're back to stellar aberration. We're just talking about stellar parallax.
Aren't they circles within circles? Isn't that what? It's a circle that's going on a nightly basis, and the entire construct is part of a greater circle that goes around in a yearly basis. So what I'm confused about is when we talk about this being a creation, how you would be able to look at that and say it cannot happen.
Because that's not the reality. We don't have layers of stars where one's going faster than the other. All those stars are going the same speed.
Right, but that's what I'm saying. It's the nightly circle, and the whole group of them is moving together in a very slight change. I mean, how much is it changing? A degree a day? Isn't that about right? With 360 degrees in 365 days. So you're talking about a degree a day, the whole system has to move, and then the circle of the stars just needs to complete one turn in every 24 hours. So it's
what's the baseline for the trigonomic calculation of stellar parallax in the flat Earth model?
I guess if you're talking, you're asking for the mathematical equation for how much.
No, see, let me just tell you what I'm talking about first. Okay. The baseline in the heliocentric system, actually in the geocentric system too, is 1 astronomical unit, which is 186 million miles. That's the baseline of the triangle that you're going to use for the measure of parallax. Right. So what is the baseline in the flat Earth system?
Well, we wouldn't use spherical geometry, right?
Well, this is not spherical geometry. This is Euclidean geometry.
Okay, Euclidean. So which is you take the longest end of a right triangle. That's what we're talking about?
No, we're talking about the base. The hypotenuse is going to be part of the parallax angle that you're making, but the base is the base of the triangle. Let's say the base of an isosceles triangle. What's your base of your isosceles triangle when you're measuring parallax in the flat Earth system?
Well, I mean, what I'm saying is, if you already have your construct completed, in which you have a value that you're placing in as a constant, then whenever the study was done on the stars where we believe they are, it would be very easy to come up with that exact same constant. It wouldn't be the same number.
Yeah, I know that. But where from what end to what end in your flat Earth, and where's the location of that one end to that other end in your flat Earth?
Obviously, this is not something that anybody has been able to study, but it's not something that we would have any problem studying if instead of studying nonsense, science was studying the truth. When you have people out there doing theoretical physics, which physics is the study of the physical reality, and they're out there just guessing, I mean, nobody knows that the sun is anywhere near as far as it is. In fact, everything we see and everything that happens on this Earth, be it getting a sunburn when you're at 7,000 miles altitude and it being much worse when you're at 1,000 miles altitude, everything tells you that the sun cannot be nearly 93 million miles, let alone 1 million miles.
Well, I would take issue with that.
I'm sure you would.
Well, let me tell you why. Okay. It would be very advantageous to the flat Earth system to have a small sun, because it would explain a lot for you. But the fact is, in the geocentric system, the sun has to carry the planets. And the sun and the planets go around the Earth in the Tychonic system. So for the sun to be the center of gravity for the other planets, it's going to have to be pretty big to carry all those planets. The center of mass.
I mean, you would not believe in gravity if you believe in the flat Earth theory. There's no need for gravity. It's a word given to either a magnetic happening or an effect of weight, an effect of density. There's no need to get into. Gravity is a concept that is needed by the heliocentrics and by the geocentrics to explain why things float in an area where they look at it and say that shouldn't be floating there. But
well, I think it's a little bit more practical than that. If I jump out of a 5-story window from a building, I'm going to fall toward the center of the Earth. You can call it gravity or schmavity or whatever you want to call it.
And we believe in that as well.
Something is either pushing me down or pulling me down.
Absolutely. And if we jump out of a building, same thing will happen to us. So now we take the next step from there. We both agree on that. Now you're saying that you're now giving gravity the strength of holding the sun, that we have to be held to the sun by some sort of same force that tells us to fall to the Earth.
No, I didn't say that. I said the planets. The Earth is not a planet. The Earth is fixed in the center of mass for the universe. The sun is independent of that. The sun has its own center of gravity or center of mass for the other planets, because all those planets have to go around the sun. In order for those planets to go around the sun is going to have to be a bigger mass than any of those planets and all the planets combined, as a matter of fact. Otherwise, it wouldn't work. The system would not work.
We don't know. What do you have a number that you assign to the sun and to the distance of it?
Yes.
What is that? That's
the
something I don't know.
93 million miles is the average. It varies between 94 million and 91 million.
So it's just, okay, I got you. I thought you were saying it was something
the mass
different.
is going to have to be about 864,000 miles in diameter. It's going to have to weigh about 10 to the 28 kilograms.
Now see, what you're saying is it's going to have to be. It's going to have to be.
Right, because we have measured Newton's laws, F equals ma, and his gravitational law in the laboratory. We've measured those things, and they work. Okay? So you just can't dismiss them as, a conspiracy of science. These formulas work.
It's not so much a conspiracy if it's people were taught something wrong. If my parents taught me incorrectly about religion, and I then teach my son about religion, it's not a conspiracy. It's simply you're not teaching the truth. So I don't like when you turn it as, well, we have to all believe in a conspiracy. I don't believe that every teacher out in every university is laughing at kids as they teach them about. They were taught the mathematics that they believe is the truth on Earth.
Of course. I'm just telling you.
Okay.
I'm just telling you that the reason we have to believe that the sun has to be so big and has to be so massive is because we've used these Newtonian equations that actually work, because we've tested them in the laboratory. And that's
work for what? To what end? What do you mean they work?
Well, if I drop a pen from my desk to the floor, that pen will go to the floor at a certain speed. Okay? Newton's laws, F equals ma, told us what that speed was. Okay? And it's correct. We can test it. We can drop that pen from a 10-story building, and it's going to accelerate at the same rate that Newton's laws allow us to calculate. So it's been tested in the laboratory, is what I'm trying to say.
Okay.
Now, if we take that and expand it to the sun and the Earth and the planets, then we have to have a certain mass of the sun that's going to carry those planets with it as they revolve around the sun.
Yeah, it's the same thing as when you say, because our sun is a bright, shiny ball, that we must assume that the rest of the stars are the same. Or people who say, well, because Mars, or because we are a sphere, means that the moon has to be a sphere, means the sun has to be a sphere.
No, I'm not jumping to any conclusions here. I'm just dealing with one issue, and the issue is how big is the sun? Okay, if you want to talk about,
you can measure the sun with flat Earth math, and you'll get 32 miles wide and 3,000 miles high.
I know. That's what started this whole conversation. You asked me if that was possible. I said no, it's not possible.
But you're saying it's not possible because it won't make everything else that you think work. But that's not what I'm asking you more to look at each individual thing, not as far as will this work in your model, because of course nothing we say would work in your model. It's the same thing as everyone who likes to disprove the flat Earth by simply bringing spherical geometry and saying, here's my geometry that shows that you're an idiot. It's like, no, your geometry proves that it is possible on paper to live on a round ball.
No, let's go back a little bit here, okay? I talked about Newton's laws. F equals ma, force equals mass times acceleration, and his gravitational law, okay? F equals m1 times m2 over r squared, okay? Those laws have been established as within the margin of error that we are able as human beings to calculate. Those laws have been established in the laboratory and they work, okay? That is a fact. So if we want to apply the pen dropping from my desk to the floor to the other bodies of the heavens, that is the sun and the planets.
So where's the sun falling?
Excuse me?
Where's the sun falling?
Where's the sun falling?
Okay, so you're saying that anything that we drop on Earth is going to fall at a certain speed. So I look up in the sky, you're telling me that those same items are all dropping then?
Well, any body that is moving in a circular motion around its center of mass is accelerating. The same as my pen is accelerating as it goes from my desk to the floor.
So you're just changing the direction of acceleration by just saying it must be that way?
No, I didn't say it must be that way. Any body that remains in a circular motion has to be accelerating, otherwise it's going to go off in a straight line.
Must be accelerating?
Right. That's basic Newtonian mechanics right there. It has to be accelerating. That's why it's F equals ma instead of F equals mv.
So are you saying then that in the mainstream model, that the Earth would have to be in a constant state of acceleration around the sun, or vice versa in the geocentric model?
No, in the geocentric model, the Earth is the center of mass for the universe, therefore it is fixed. It doesn't move. It either has linear motion or circular motion or any motion at all. It's not accelerating at all. The only thing that's accelerating is the universe itself as it rotates around a fixed Earth.
And things that my pen.
I'm sorry, what?
And my pen or whatever I'm dropping to the ground is also
right. Yes.
Okay.
Yeah, and you can measure that. It's 9.2 meters per second
right.
Is the acceleration that's going to occur.
Nobody's arguing with that, but we would all argue that what happens at the ground layer of Earth is not the same as it would happen at 1,000 miles high. So I wouldn't then just address whatever's happening to me around my body right now as far as equations. I need to now come up with a way that matches also what I see in an area I can't even get to, that nobody can get to. I mean,
well, yeah, but see, the thing is, we do see these things go around us every day. We see the sun go around us, we see the moon go around us, we see the stars. So it's like a merry-go-round. That's not too hard to explain, you see.
Right.
So we just transfer a set of laws that we've established in the laboratory on Earth to what we see in the sky. Now, grant you, okay, we might all be wrong, okay? There might be bunnies up there that I can't see pushing the sun and the stars and the planets, okay? That may be the case, all right? But I can't see them. So I'm not going to go make a scientific theory based on bunnies pushing the planets. I'm going to base it on the force laws that we've established in the laboratory to have me extend now to the cosmos to at least give a plausible explanation of what's happening up there.
So how would you then address dark matter and dark energy if you're saying you're not going to do applying things to things you can't see? It's worse than the bunny theory to say, well, gravity's not matching what we see anymore. We'll just call it dark energy and dark matter. It'll make up 95% of the known universe. We'll teach it to kids, and everyone else just believes it because we say we're not changing gravity. When we could have looked at things a different way and said, hey, maybe what goes on up above our heads doesn't have to match what goes on Earth. But instead, they've created this, it has to be mathematical. It has to work perfectly on our paper, on our human-created math sheet. The whole universe has to go by my math and nobody else's math. And Einstein was a genius, and he came up with this, and we're not going to change it no matter what. It's If
there's something strange in your neighborhood, who you gonna call? If there's something weird and it don't look good, who you gonna call?